and welcome to the Daily Space Weather. Today we're looking at zero sunspots, some alternate data, some maintenance on some important websites that we regularly use, a cosmic ray update. So please subscribe and share. Let's take a look at some limited imagery of the sun here. Here's a magnetogram from solarmonitor.org, and I want to zoom in on this area in the southeast to show you zero sunspots. So this is a magnetogram, and this is the active region we're looking at here, not a sunspot. And we've got issues with the SDO and the SOHO sites because of maintenance. We'll show you some more imagery momentarily. First, here's the solar system. And there's where things will be in a week. Here's a star chart. Not a lot to say there. If you're up before dawn, you may see this scenario going on. You can use in-the-sky.org to make yourself a custom star chart. I face mine to the south. I'm currently facing the south. The radio flux of the 10.7 centimeter variety, the radio output of the outer solar corona at 73. Solar flux units just barely over solar minimum conditions. There you can see the 1 year chart of the radio flux, which is the upper black line. 73 solar flux units. And there is the context through cycle 24 and into cycle 25. So we've got zero HelioViewer movies for you. However, we do have some intensity grams here. So I'm just going to show you yesterday's extreme close-up of this active region in 171 angstroms. If you want to see more views of that, check out yesterday's daily space weather video. And this active region is not a sunspot, just a magnetically organized area, otherwise known as a plage, which also means a sandy beach, as they look a little bit like one. So here we've got some of the most updated imagery here. And you're looking at the intensity gram from the telescope in Udaipur, India. So we're going to zoom in on this southeast region here to show you that there is no umbra. You can see a little bit of a light spot there. Little bit of a light spot right about there, but no dark umbra, and so that is not a sunspot. I wanted to note one other thing that you can find at the National Sunspot Observatory site. You can find the helium alpha. I'm sorry, the hydrogen alpha. So this is the 6,562.8 angstroms. And that little distortion you see there, that's an obscuration event. Anyway, we'll be using this in the future as the the hydrogen alpha data is important. And so you can see the timestamps there. At least we got some current imagery of the local yellow dwarf here. Cheers. Again, you can find all of that at the National Sunspot Observatory. Are you interested in what volcanoes are erupting? Well, I am. It looks like an uptick as there are more volcanoes on the list here at volcanodiscovery.com. Kluchevskoy, probably erupting, although volcanic ash not identifiable in satellite imagery. Ibico, producing a 10,000-foot ash plume. I think that's an uptick at Ibico. Sakurajima, flight level 060, 6,000-foot ash plume. Sakurajima exploding, flight level 040. It's a 4,000-foot volcanic ash plume. Mount Ibu, down in Indonesia, flight level 070, 7,000-foot ash plume. Popocatépetl, 20,000-foot ash plume over Central Mexico, Fuego exploding, 16,000-foot ash plume, Sangay exploding, 19,000-foot ash plume, Revenador exploding, flight level 150, a 15,000-foot ash plume. And although we're unable to detect volcanic ash from satellite imagery and so on from Sabancaya, please do not attempt a triple back layout with a full twist over the caldera. It could be unhealthful. Largest earthquake of the past 24 occurred as I did show prep today. We'll get to it at the end of the list. And we see a swarm of quakes on the west coast of the U.S. as well as a deep quake near Fiji at over 580 kilometers. So a series of quakes there in California and Nevada. There are the locations of those, as well as some up by Portland. Some Cascadia quakes kicking off. And let's just go back to the list. None of those quakes were major. Here's another deep one near Timor-Leste at over 400 kilometers depth and a 4.3 magnitude. There's a 5.6 at the Philippines. I stand corrected. That was actually the largest of the past 24. I think that 5.6. However, this 5.4 did happen while I did show prep. It was at 338.7 kilometers estimated depth and a 5.4 magnitude just north of New Zealand in the deep earthquake capital of the world. By the way, I would invite all of our viewers to check out our own websites. smAshomash.com, smAshomash.org will redirect you. You can find links to our forum and our merch shops. The forum's been updated. Thanks to Smash staff for starting a new thread on recipes. So yesterday's chili con carne recipe has been posted. And here's what we were eating near the beginning of the Super Bowl. Oh yeah, it's good times. It's our homemade custom chili recipe. And we did make some tweaks. We added green and poblano peppers. And this is designed as a crock-pot recipe. So if you want to post recipes, one more item there at smashomash.com/forum. It's all free. Just set up a login, post whatever you like. We won't censor you. Don't make a fool of yourself. Because again, we won't censor you. As I am a firm believer in the idea that the solution to bad speech is more speech. We're not part of the cancel culture, folks. We are indeed alt tech. So please press like and subscribe over on YouTube. We need your assistance to get the videos out there as we can't rely on the algorithms. We see a rather stagnant growth in subscriber count and so on. So please tell your friends, foes, science noobs, and science pros about the content. Share on your social media, press like, subscribe, leave a comment, etc. And thanks to all of our new viewers, as well as loyal regulars over at YouTube. This smAsho stream was actually streamed live to Twitch. Twitch.tv/smAshomash is the URL for that. They've got a great free mobile app as well. And the streaming platform is fantastic. Twitch.tv/smAshomash. And let's do a cosmology segment real quick. First, cosmic rays. Here are two cosmic ray monitors, Apatit and Barentsburg, and you can see a downward trend here over the past 30 days at Apatit, as well as at Barentsburg, slightly down at both of those cosmic ray monitors. Next, we'll look at Athens, Greece, by going much farther south. And there is the neutron monitor at Athens, and we've got erroneous data there in the past 6 days. Next, we'll go even farther south to Mexico City. And we actually see an uptick in cosmic rays here over the past 30 days at Mexico City. There is your 30-day graph on that. And next we'll look at Oulu, Finland, and 2 Antarctican monitors. Here's Oulu, Finland. A downtick over the past 30 days there. Here's DOMB Antarctica. An uptick at DOMB Antarctica over the past 30 days. And DOMC Antarctica, flat over the past 30 days there. If you want to monitor these yourself, don't take my word on it. Look up links to cosmic ray data, and you'll find this network of cosmic ray stations site. Next, I'd like to thank our patrons, who are indeed stellar. Thanks, patrons, the true source of funding for the content as we make just this side of nothing on the YouTube videos. We've leveraged ourselves to know what's going on in space because of the space race. Are you a space case? Are you spaced out? Well, please consider becoming a patron at patreon.com/smAsho to increase the probability that these videos will continue to exist, much less be publicly visible and free. Practically every day we consider delaying the videos a full day and showing only the patrons the most current video. Not doing it yet, though. To continue the cosmology segment, let's do a random die throw here between the numbers 1 and 1031, which will coincide with an object over at the Neil Gorell Swift-Bat X-ray Observatory. Today's object is 747. And I think we may have covered this one already. We may have to go back for a second number here. Nope. It's GX9+1, a low-mass X-ray binary/neutron star, otherwise known as Sagittarius X3. So here are the transient X-ray outbursts from GX9+1, otherwise known as Sagittarius X3. And you can see it's a very consistent X-ray source there, with a bit of a periodicity showing up there, almost like an annual periodicity. And there's the 30-day chart. It looks like there may be some missing data at the Neil Gorell Swift Burst Alert Telescope. Let's see if we can get some imagery of Sagittarius X3. Nothing showing up on Simbad. Let's go to Aladdin Light to look at some additional wavelengths. So let's see if we can see it on the 2-mass in infrared light, and indeed there is a heaping helping of nothing there. How about the Chandra? And there you can see Sagittarius X3 on the Chandra. That is the X-ray frequency located in the constellation Sagittarius. That low-mass X-ray binary consists of a massive radio source, which some would refer to as a neutron star. We'll just call it a massive radio source. And it's being orbited by something, or it's orbiting something. How about the XMM Newton? Does it show up on the XMM Newton? And it looks like a box on the Multi-Mirror project. How about the Fermi? Not really showing up in gamma ray. Anyway, there it is on the Chandra X-ray telescope. That's today's object, is Sagittarius X3, otherwise known as GX9+1. Some catchy names there. And that's today's cosmology segment. Maybe we'll cover more on that at a later time. Perhaps tomorrow's Daily Space Weather video will have an update about Sagittarius X3. And let's get back to data. No significant solar flares going on. There is the X-ray flux over the past 3 days. And for you new viewers out there, the X-ray flux is measuring the intensity of X-rays in watts. So watts per meter negative squared. And this is measured at the F ionosphere layer. So at about 300 kilometers altitude, we've got this spacecraft called the GOES-16, which makes tons and tons of very important measurements One of them is the measurement of the X-ray flux. Since the mesosphere absorbs nearly all of solar X-ray emissions, we need a spacecraft to measure that, and the GOES-16 is the go-to spacecraft for the X-ray flux. The X-ray flux is important as it's one of the most important indicators of solar activity. There are many different variables that the sun is outputting. So some higher intensity photons, very different from the 10.7 centimeter radio flux photons. The other end of the electromagnetic spectrum would be the X-rays. And so it gives us great insight. We tend to see greater numbers of X-rays when we see solar flares, an indication that fusion is happening on the surface of the sun. Next, the proton flux. And this is just the incoming particle stream. The particles that make it all the way down into the Ionosphere layer is what's being measured with the GOES proton flux. So we're measuring three different energy levels here. 10 mega electron volts, 50 mega electron volts, and 100 mega electron volts. It's greater than or equal to all of those. So greater than or equal to 10, greater than or equal to 50, or greater than or equal to 100 mega electron volts are the three lines you see on the GOES proton flux image. And the main output of solar wind is indeed protons. It's like 90% hydrogen nuclei. And those things really want an electron. Let's take a look at the real-time solar wind here. And we see a subsiding real-time solar wind. We were in geomagnetic storm conditions. We reported on it on yesterday's Daily Space Weather video. If you want to hear about it, watch yesterday's Daily Space Weather. In any case, current solar wind density about just under 5 protons per cubic centimeter. Current solar wind speed having ramped down from its highs at about 550 kilometers per second, now down to 459. Still an elevated solar wind speed. So there you can see that geomagnetic storm condition. The KP index is a measurement of global geomagnetism. And we were in unrest for 2 brief periods and in geomagnetic storm conditions for 3 to 6 hours there, as each of those bars represents 3 hours. Here's the last 4 hours of magnetohydrodynamic pressure as modeled by the Space Weather Modeling Framework. And this is the Geospace Magnetosphere movie section of the video. Nothing too surprising there. We see greater pressure in the magnetotail. The sun would be off to your left in that image. Next, looking at changes in the Earth's own B field here. Magnetic perturbations on the ground. Delta B in the geospace. Changes in the Earth's B field. And the denser and faster solar wind we see, the more geomagnetic perturbations we see. It's caused by the induction caused by solar protons. Next, looking at the GOES magnetometer, as we are interested in the magnetic fields. Once again, this is measured at the Ionosphere layer at about 300 kilometers of altitude. And we see continued low readings here, as I've forecasted. That's a 3-day chart, the GOES-16 magnetometer. And these arc jet moments that you see here, these are points when the GOES-16 creates plasma by turning on its thrusters to make sure that it's at the proper location. And when it does that, that plasma can affect the magnetometer measurements, so it puts in those arc jet moments. Next, we're looking at the Gong2 data here. It's the top view ecliptic plane field plot, which will show you the polarity of the heliospheric current sheet. So you can see the Earth is solidly in a south pole current sheet shown there in red. And we're going to continue to see those low readings on the GOES magnetometer for the next foreseeable day or two. Keep in mind the magnetic data can suddenly change, and this data, 1 hour and 20 minutes old. Here's a line of sight field plot. And not a lot of magnetic organization on the sun. The only real region of activity is this plage in the southeast corner. Although there is a coronal hole leading that, it is South Pole oriented. You can see that in red at the bottom of the image. And no images of the solar coronal magnetic field today. Here is first of all, here is me vanishing and checking the life of the stream. And we are good. Here's a diagram of the atmosphere in kilometers. And you can see by the time X-rays reach the mesosphere, by the time they reach the stratosphere, they're all adsorbed by the atmosphere. This is where the GOES 16 makes its measurements at the Ionosphere layer, or at least it endeavors to. And you can see around 300 kilometers altitude. Here's another diagram showing you the Van Allen belts as we're moving into electrons next. The Earth is surrounded by giant bands of electrons known as the Van Allen belts. And we've got 2 of them most of the time. This is a cutaway of it, as these go all the way around the planet. And at times of geomagnetic storm, we can actually get a 3rd Van Allen belt forming as a result of the geomagnetic storm. And those Van Allen belts can cause satellites to charge up and be damaged. Right now, we don't see any charging hazards as electron flux is at a low level. And there you can see the 3-day chart, once again measured by the GOES 16. The greater than or equal to 2 mega electron volt electron flux. There's the 1-year chart to put it in context. And here's a visualization. And the closer to red you see here, the more likely you would be to have a significant GPS error. Nothing too exciting going on there on the total electron content forecast. And the forecast, once again, is for a small uptick, followed by a larger uptick. And I have no reason to disagree with those. I would tend to agree with those forecasts, although we may see a larger uptick a little sooner than this forecast indicates. We won't get into it in how to forecast that. It's too much for the daily space weather. Here is a map of just the ionosphere. So this is around where the GOES 16 is making its measurements. And this is in megahertz. This is the frequency of vibration in the ionosphere. This data is provided by Australian Government Bureau of Meteorology. Ionosphere looking pretty normal to me. Here is the latest image coming in at 9:45 Universal Time. Next, looking at jet streams. Here are the jet streams of the Western world. I think I had some cayenne stuck in my throat, folks. And look at the extreme meridional jet stream flow here. You've got the jet stream breaking off and going straight toward the pole. Look at these extreme bends down in the southern hemisphere, all over the place. An incoherent jet stream. And if you think that's caused by the galactic current sheet, then I think you should seek a psychiatric evaluation. Because the galactic current sheet is nothing like the heliosphere at all. We've got an area of extreme jet stream activity right here in the southern Indian Ocean there. Let's take a look at the surface winds and see if they translate. This is the 250 hectopascal winds. Let's check surface winds. And indeed, there is a powerful system down there. What are the wind speeds? Yowzers. That is a hurricane force cyclone down there. As we easily showed. There you go, 93 mile per hour winds on the surface there, shown by nullschool.net. And it translates all the way into a jet stream level disturbance. On the east coast of the U.S., we would call that a hurricane, as it is approaching Category 2 levels. And look at the jet stream, how kinked it is down there. It's all over the place, folks. And indeed, it is blowing backwards over the central Indian Ocean. Jet stream blowing east to west instead of the normal way, west to east. Here's the U.S. Doppler radar map. It's a value-added service. Oh my God, it's more snow in the Midwest. Here are pressure cells. This is on windy.com. They've got a great mobile app as well. And once again, look at the massive high pressure here over the northern hemisphere. The entire northern polar region surrounded by high pressure. The entire southern polar region surrounded by low pressure. What is up with that? It's not caused by the galactic current sheet, I can tell you that much. Next, looking at the advancement. This is the GFS forecast for pressure. This is where we expect pressure to be at 1 p.m. tomorrow, Eastern Time. Here's what's going on in the cloud layer over the lower 48. Here's a water vapor map. I would note all the low clouds over the Atlantic Ocean once again. Low clouds, big time, as well as a bunch over the Gulf of Mexico as well. Yes, low clouds, folks, low clouds. They're not chemtrails. They're not contrails. They're low clouds. And yes, contrails are pollution. Contrails make the planet cooler. Contrails can cause clouds to form. That is a real thing. And by the way, today, we ain't got no bonus features because the SDO site is toast as well as Soho. So thanks, Smash Team, for tuning in. Please don't forget to press like, subscribe, share on your social media. Leave us a comment. Visit our websites. Maybe become a patron at patreon.com/smashamash. I've been your host, Dan, a.k.a. smAsho, and that is all we've got for you today. Thanks once again for tuning in. Allow me to vanish, and may that solar wind be at your back and that data at your fingertips. It's expected to come back around 1500 Eastern Time, by the way. Smash News Network, least busted name in news.